Good morning. I'd like to go over something that is not in the book, so you should pay careful attention to what we're talking about here. And what I want to do is I want to talk about let's talk about a full adder. And you may remember for a full adder, we had a couple of inputs, the bits that we were adding, and there was something called the carry in. And then what happened here is we had the sum and we had the carry out. And we go ahead and we make our truth table. And let's go ahead and fill this in. So this is 0, 0. This would be a 1 and a 0. This would be a 1 and a 0. A 0 and a 1. 1, 0. 0, 1. 0, 1. And a 1, 1. And here's what I want to note. Let's just focus here on the sum column, okay? And we see that there are these instances here where I have 1s. And that would correspond to that. And this over here corresponds to that one. And this corresponds over here to that. So if I were to say to you, when is the sum is 1, we would say sum is 1. When. And now we have a whole bunch of different things to talk about. We could say not A and not B and C in, or, and then we come down here to this next line, and that would be not A and B and not C in, or, and you get the idea, okay? And there would be 4 of these terms here. 1, 2, 3, 4. And what's going on here is you'll notice that we're ANDing each one of these rows, and then we're ORing the rows. Now, very frequently in logic, we come up with some shorthands for writing things. And first of all, one of the things that we'll do is if we want to say A or B, sometimes we write that using a plus sign. Very frequently do that. And when we want to say A and B, what we do is we use the multiplication sign. And sometimes we actually forget, we don't even put the dot in there, we just do that, it's implied. And the other thing that we do is sometimes when we want to say not A, we just write an A and a prime. So if we want to come back over here, if I want to say not A and not B and C in, I might write that A prime, B prime, C in. And if I wanted to come over here and say not A and B and not C in, that would be A prime, and let's see, not A and B, and then not C in, we would say C in, and I'd put a prime there. And in fact, if I wanted to come over here, I could completely rewrite sum and say sum is this way. I could say sum is equal to, okay, I would say A prime, B prime, C in, or A prime B C in, or I come over here, this line over here would be A B prime C in prime, or the last one down here would be A B C, like that. And what we have over here, this form that we have over here is sometimes what's referred to as the sum of product form. Okay? The other thing that I want to introduce you to is this notion of what's called a minterm. And the idea here is that you could think of, let's look at this term right here. Suppose I were to have A prime, B prime, C in. What I do is if something is primed, I make that a 0. So this would be a 0. And if it's not primed, I would make it a 1. So this A prime, B prime, C in, that's 0, 0, 1. That corresponds to 0, 0, 1 right over there. And I would say that this is the minterm 1. Okay? If I were to come over here and say, look at A, B prime, C in prime, A, B prime, C in prime, well, that's 1, 0, 0. And that would be 1, 2, 4. That's the minterm 4. So another way to write sum here is we would say that sum is equal to, well, it's minterm 1 plus minterm 2 plus minterm 4 plus minterm 7. Very frequently, they write it this way. One, 2, 4, and 7. So we have a couple of different ways for writing this. We could say sum is equal to this. We could also say that sum is equal to this thing over here, this whole long term. All right, so we have over here our full adder. Let me just arrange the screen a little bit. And I'm going to need some more writing space over here. And we're just interested in the sum. So there are a couple of things that I want you to note over here. So we note that the sum was the sum of these products. This one plus this one plus this one plus this one. So first of all, I want to note that sum is a function of 3 inputs, A, B, and C in. Okay? And we wrote over here, down here, we came up with this sum of product. Okay? And we also said that sum was the sum of the minterms 1, 2, 4, and 7. Well, what I want to note is the following. This is that I'm going to call it sum complement. Seems like kind of a funny thing here. Okay, but sum complement would be this one plus this one plus this one plus this one. Or in other words, that sum complement would be equal to, well, I come over here, sum complement would be A prime, B prime, C in prime, or I'm going to come over here, and let's see, that would be A prime, B, C in, Okay, that corresponded to this row right over here. Or, okay, over here it would be A, B prime, C in, A, B prime, C in, or, and then this very last row here would be A, B, C in prime. Okay, so remember what I'm doing here, this is sum prime, which is, by the way, this is also equal to the sum of the remaining midterms. And what midterms are those? Well, that would be 0, comma, and this over here would be 3, comma, and this one over here would be 4, 5, comma, and this would be 6. Okay, so again, what I want you to notice here is that when I looked at, I need to move this over just a little bit. I want to try and keep it on the screen. Let me see if I can do that. Yep, I can. Notice that when I was looking for sum, remember the midterms go from 0 to 7. Okay, so that when I was looking at sum, over here I got 1, 2, 4, 7. Well, sum prime, the inverse of sum, are just going to be the ones that I didn't pick, 0, 3, 5, 6. But now, here's what I want to do. This is the whole point of this particular lecture here, is I want to come over here and I want to complement both of the sides of this. That might seem a little bit weird, but if I go sum prime prime, that of course is going to give me sum back. But that's not what I'm looking for. Well, it is what I'm looking for, but here's the point. I've got A prime, B prime, and I'm going to stop writing C in. I'm just going to leave it as C for now, and that's a C prime plus A prime B C plus A B prime C plus A B C prime. But now the whole thing about this is I'm going to prime this. And now sum prime prime just gets me back to sum. And here's where the really cool part comes in. What I've got to use over here now to simplify this expression is I want to use De Morgan's rule. And remember what De Morgan's rule is going to do. It says what I'm going to do is I'm going to distribute this not over the terms inside, and I'm going to turn multiplication into addition, or in other words, I'm going to turn an and into an or, and I will turn ors into ands. So what's going to happen here is first of all, I'm going to distribute this not over these terms here, but what's going to happen is whereas before I was anding these together, now I'm going to or them, and that's going to become A or B or C. Okay, does everyone understand what's going on here? Notice what I did is I applied this not over each one of the individual terms. Well, not A gives me A, not B gives me B, not C gives me C, and what happened is the ands became ors. Okay, now this is going to become an and, so I'm just going to put a dot there for emphasis, and I come over here. And now what happens is I have to do the same thing again. Well, not A becomes A, or this is going to become B prime or C. And now what's going to happen over here is this is going to become A prime or B or C prime, or, and what's going to happen over here is I'm going to get A prime or B or C. And now here is the whole point of this discussion now. Notice what I've done here now is I have a completely different way. Here is the old way that we expressed sum, and notice that that was called a sum of products. Over here I have a different way of expressing it, and this is called a product of sums. Okay, again, I'll show you the old one. Let me see if I can squeeze this all on one screen. Somehow it does not look like I can. Here I have a sum of products for sum. And over here I have a product of sums. Maybe I can rewrite it here. A prime, B prime, C, or A prime, BC, or A B prime, C prime, or ABC. So you can see here, and remember, so this is product of sum, this is sum of products. The point here is I have two different ways of writing exactly the same thing. Okay? And in general, I can do that for any Boolean function I like.